Okay. Do any of the others of you have questions before I get into my spiel? Okay. Here's what's going on, and this always takes longer than I want it to take, but I'll try to explain things. I think I've told you before that I do have a mild form of leukemia. I've had it since 91, probably before some of you were born. It's, the white cells, some white cells just increase at varying rates, and at some point I have to go in and have treatments and they knock them back down again. They say so far they can't cure it, but they can treat it. So I've been living with it for however many years. 91, that would be 29 years, I guess. No, more than that. Yeah, 29 years. Okay. Wow. Okay. Hadn't thought of it in those terms. Well, at the first of the year, I had a treatment. My white cells were high. They did a treatment. I'm on what they call a monoclonal antibody, which are really amazing medicines, you might say. There is, I guess, technically a form of chemotherapy, but it's not the harsh kind. They've been designed to attack just the markers on the cells that are malignant, that are cancerous, So, and they do a tremendous job. I've been through, this is my third one I've been on. I was on the old chemical drugs once for 4 rounds back when the counts got really high early on. And then ever since then, I've been on monoclonal antibodies. The one I'm on now is incredibly effective, just amazingly effective on me anyway. Others may be more effective on other people. Different. It depends on which cell happens to be the one that's malignant. So the ones that I have, this one knocks it out. So I had a treatment back in January before spring term started. And I went in for a checkup then in March. This is approximately, I can't remember exactly the dates, in March to see if I needed another treatment. Well, in March, oh, here comes Morgan. Let me get Morgan in here before I yak too much longer. Okay, so Morgan's here. Okay. Now, Morgan, I'm just describing one reason I'm behind on Blackboard, I'm behind on email, I'm behind on grading, I'm behind on everything. This is my sad, sad song. You can hear the violin music in the background. I had, I have, a form of leukemia, and I'm right now on a monoclonal antibody, which is really, really effective on it, but, I have to have treatments every now and then. I had a treatment back in January, the very first of the year, before actually school began. And in March, I had a visit with the doctor to see if I needed another treatment. The 3 months after the treatment, my white cells had gone from whatever they were really high to within the range, in the lower part of the range of where they should be. So, nope, no treatment. Oops, here comes Damien. Let me get Damien in here. And this is one reason I don't mind talking too much about this stuff at the beginning, because you have students coming in, and I'd rather they miss listening to me than miss listening to Trig. So anyway, I had the counts in March were still in the low part of the range, so no problem there. Come back in June, or sometime around June. So around June, I went back, and if you recall, June was about the time the coronavirus was just going crazy. Not as crazy as it is now, but at the time it was really scary, very scary, and it's even scarier now, but we didn't know it would still be. So at that time, my counts were about 18 to 19,000, and the high range was 11,000. But because of Corona and COVID-19, the doctor said, let's just wait another 3 months. Maybe COVID-19 will get a little better. So that was fine with me. So I went back about 3 months later let's just say September, October timeframe, whenever it came up. And I went in to have the accounts done, and this time they came back. And this is how this disease is. It just goes crazy sometimes. They were, let me see if I can remember exactly now. I think it was about 140,000. I mean, they went through the roof. In those 3 months, they went from 19,000 to about 140,000. You need a treatment. Okay, so that was the day that we had to miss class. Remember, they gave me a 10% treatment on this was about 4 weeks ago from tomorrow. Okay, well, 4 weeks ago from today, I had to miss class because they did 10% of the treatment on the first day and 90% on the second day, on Friday. Well, that first day, that Thursday, when I was getting the treatment, I could tell there was a battle going on inside. I could tell that drug was knocking these things out right and left. I was so hot, I just couldn't believe it. And I just asked them to give me some crushed ice, and I was there eating crushed ice for a couple of hours, and slowly the heat went down. I felt a little better. I never could get any good sleep, even though they had given me Benadryl. But anyway, that was it. When I went back the next day, I thought, what is 90% going to be like if that was what the 10% was? Well, the 90% was next to nothing. I could feel it was doing some stuff, but it was just not nearly as intense as it had been the day before. Took a little longer because it had to do more drug, but I went home and it was no problem. However, when they did the blood work before the treatment, they said I was severely anemic. Okay, I didn't realize that. As it got closer to treatment, because it took a few days for them to schedule me, I was getting tireder and tireder, and I could feel, I think I've mentioned in class before that I was anemic, and it was, I was feeling it more and more. And then after the treatment, my word, was I ever exhausted. Okay, I mean, not just the day after the treatment, I meant that next week or two. Walking upstairs just wore me out. Okay, and we live in a 2-story house with a basement, so there's actually 3 floors in it. And then trying to do stuff in the yard, trying to do stuff at the farm, trying to do stuff at the lake. It was just, I would just wear out with no, with not much effort. And even at night, I could hear my pulse beating. I mean, I don't normally hear my heart beating, but I could tell it was, and I knew it. I hoped it was just the anemia, that it was just having to pump harder and more blood, trying to feed everything. Well, in the 3 weeks since then, not every day, but every few days, I could just sense I was a little bit better, not hearing my heart as much, not having as many problems. But I still get tired walking upstairs and things like this, but not nearly as bad as before. Well, I went in. They were scheduling me a treatment for tomorrow, which I did not think I wanted to have a treatment for tomorrow because I'm still feeling so weak from the anemia. So I sent them a thing in the portal saying, can I have my blood work done on Wednesday rather than waiting till Friday? Well, they didn't respond on Monday, and finally about 5:40 in the afternoon, they finally got around to responding, said, yes, we'll put in the order. You can have it done anytime tomorrow or Thursday or Friday morning. So I went in early Wednesday morning, yesterday morning, to have my blood work done. And I was on the way home, I guess, when the nurse saw the results. And because I had my phone in my pocket and I don't like answering when I drive, I didn't even hear it go off. I had it on mute because I usually have it on mute when I'm teaching. But I didn't hear the vibration or the buzz or anything else. And sometime after I got home, I happened to see that I had missed 3 messages from the nurse. So I called back, and my nurse was busy with something else, so I talked with another one, and she looked up and saw what the message was, and she said, "You are extremely anemic." Now, this is 3 weeks, almost 4 weeks after the treatment. She said, "You are extremely dangerously anemic. You need to come in Friday and have a transfusion." Not an infusion, not the drug, but a transfusion. And they said it also at the time. The drug was incredibly effective on the thing. So it was about 150,000 counts by the time I had the treatment. It had been 140,000 the few days before, or a week or so before. It was 150,000 by the time I had the treatment. It was down to 1.4 thousand, way below the minimum. The minimum is supposed to be about 4,000. It was down about 1.4. That was the white cell count, but the red cells were basically what they're saying, dangerously low. My platelets were dangerously low. My neutrophils were dangerously low. Everything was, had been, just hit and hit hard. So they had me go back to the clinic yesterday to get typed for the transfusion tomorrow. So therefore, I lost my office hours in the morning, or a lot of them, because I had to go in for the blood work then. I lost them again in the afternoon because I had to go back for more blood work, and now I'll lose them all tomorrow because I'll be having the transfusion at the clinic tomorrow. I'm going to take with me as many things as I can print off today, which I don't have a lot of time today. I have 2 hours in the afternoon. Well, part of that is when I eat lunch, but I'll print off as much as I can today, and I'll take with me when I'm in the clinic. I'm hoping with the transfusion there won't be any Benadryl or anything else that'll make me sleepy, and I'll be grading papers while I'm in the clinic. And it takes, they say, 2 to 4 hours to do a transfusion. So that's a very long answer to your really simple question. So I think you said you sent it by email, so I will check email first this afternoon and print off as much stuff as I can off email. Then I'll go back and print off things off the blackboard in as many classes as I can. But at some point, I have a lab this afternoon that's going to take a class with lab, mini-term class with lab, that takes 4.5 hours. So from 3:15 until 7:45, I can't be printing very much. So maybe we'll end the lab a little early today. We usually do. So I may be able to print off some stuff tonight too. So I'll be grading papers if I can, if I feel like it and feel good. And they say, actually, I should feel much better after the transfusion, and maybe even during the transfusion, than I do right now. So hopefully I'll be able to grade papers then. So sorry, such a long answer to your very simple question, but I'm going to try to get caught up. And then, of course, next week is Thanksgiving week. We're not having anybody over. I don't think we're going to be going anywhere. We may. My wife's mom's 84th birthday is Friday, so we may go up to Huntsville to see them on Friday, or it may be just my wife will go and I'll stay home. I'd love to see them, but if I am in very vulnerable state, I don't want to risk anything. So anyway, hopefully next week I'll have some time to get caught up on grading as well. All right, any other questions? I hope I won't give that long of an answer. Any other questions, issues, concerns? And by the way, folks, if you haven't registered for spring term, please do so. If you can, get it done today. If you can get into the virtual advising center, do that and get advised and then register. If you are and want to try it, go to campus today. They are registering students from now, it actually started at 9 this morning, until 7 this evening. Someone will be there to help you, advise you, and help you register. They can't register for you. Only students can register themselves in this new system banner that we have, but they will help walk you through it. Okay? So please try to get registered today. All right, any other questions, issues, concerns? All right, what I'm going to do now, well, let me make sure there's nobody in the waiting room that I can tell, and I think I've got more people here than are in class right now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. No, we're caught up. So we've got everybody here that's come in so far. So let's go to 5.5, and we're on Chapter 5, Analytic Trigonometry, Section 5.5, which is multiple angle and product to sum formulas. We're sort of in between the two of those. We're in the half angle formulas, which I guess in a sense is a multiple angle. It's just not a big multiple, it's a small multiple. So I'm going to first go to current slide, and I'm going to move my, you can't see it, but I have a toolbar that decides to put itself right in the PowerPoint slide. And while we're here, let me go on and set up for the whiteboard so I can get that set up, because I know the odds are I'll be using that before the morning's over. And we'll move the whiteboard as much as I can to the left and up. Okay, so let's go back to the PowerPoint. Five. Okay. Okay, that's not what I needed. Okay. Now I don't know how to get out of this. Resume slideshow, that'll do it. Okay. So we're going to talk about our half angle formulas. Now if you recall the power reducing formulas, I'm going to go up a few slides to show those to you. There they are. Okay. Now here we looked at them as if they were reducing the power from a square to a first power, second power to first power, second power to first power. Okay. But if you look at that carefully, imaginatively, creatively, you can see you're going from a single U to 2U as well. Or if you do it the other way, you could call this a half angle formula. How you get from 2U to U. You got to rearrange it, and in fact I think I'll rearrange it on this slide. Now here's something that's scary. My pen is nowhere. There it is. Okay, that's an expensive ionizing pen that I write with on my tablet here. So what we're going to do is solve this for U. Okay. Okay. So this will be, take a square root of both sides, and you get sine U is equal to the square root, and it's a plus or minus the square root of 1 minus cosine 2U over 2. Okay. Now let's change their names. Okay. Now what do I mean by that? Okay. Let's make this, I'm sorry, I did too much there. Let's make that a U. Okay. And that would make this a U over 2. All we did was take half of that and half of that. There's your half angle formula right there. Okay, for cosine of u over 2 would be plus or minus the square root of 1 plus cosine u over 2. And the tangent half angle formula would then be tangent of u over 2 would equal plus or minus, it should be a single minus, the square root of 1 minus cosine u over 1 plus cosine u. All you do is change the u to u over 2, make the 2u u, it's just half of that, and then solve for the square root, so it gives you plus or minus. So it's nothing too new, okay? Something we just had, you're just changing a couple things about it, and that's where we get, I'll get there in a minute, the half angle formulas. You can derive some useful alternative forms of the power reducing formulas, which I just did, by replacing the u with u over 2, and these are called the half angle formulas. So now, the sine of u over 2 was plus or minus the square root of 1 minus cosine u over 2. Cosine u over 2 is plus or minus the square root of 1 plus cosine u over 2. This is a minus, that's a plus. Now, notice the tangent u over 2 doesn't look the same. Oops, here's somebody coming in. Can't see who it is. Oh, that's Bennett. So he must have had to bop out or got bopped out and then come back in. Hold on just a minute. I just noticed something I forgot to do on the roll, and I like to do that before I forget it. I'll be back with you in just a second or 2 or 5. Okay, I thought I was short a person. So now we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I should have 13 here. Yeah, I do have 13. Okay, good deal. Glad you're back, Bennett. Okay, now what I was going to say, our tangents don't look the same. So let's go back those slides and see, whoops, I can't go back those slides. See if we can figure out how they got those tangent formulas. Okay? Okay, so I'm going to do this underneath here. Here's what I'm going to do. I'm going to multiply by a conjugate, which is a good trick to do just about any time. Make this 1 minus cosine. I'll leave it to u. Later I'm going to change that to u. I think I'll go on and erase this other one because that's not the one the book uses anyway. Or I could have done it inside the square root. Maybe I should have done that. But this is easier to do it here, I think. We'll see. Okay, but if you multiply the denominator by that, you got to multiply the numerator by that as well. Minus cosine. Let's go on and change that to u. I don't want to write 2 u's if I don't have to. And this will be u over 2. Okay, so make that 1 minus cosine u. Okay, and when you multiply this, what you wind up with here is, in the numerator, 1 minus cosine u squared, because it's 1 minus cosine u times 1 minus cosine u. Down here, on the other hand, you get a 1 minus cosine squared u, because when you FOIL this, you get a 1 plus cosine u minus cosine u, and those add to 0, and then you get minus cosine squared u. 1 minus cosine squared u is sine squared u. Right? 1 minus cosine squared, it's Pythagorean identity. So now when you take the square root of both sides, what do you get? Tangent of u over 2 is a perfect square up here, so you take the square root of this and you get 1 minus cosine u over sine u. Okay, that's one rendition of it. Okay, now what I'm going to do is erase part of this. Oh, I could have done better. Okay, but I'll clean it up a little bit. Okay, so there's one new form. Okay, let's do the other form. This time we're going to multiply by the conjugate of the numerator, 1 plus cosine u. But if you do it there, you got to multiply by 1 plus cosine u here, because that over that is 1. So what you have up here is 1 minus cosine squared u, which is sine squared u, and down here you get 1 plus cosine u squared. And then when you take the square root of this and the square root of this, you get sine u over 1. And here comes Sharika. Good deal. Okay, let me get Sharika marked here, and we will move on from there. Yo, I'm dropping my pad. That's the problem with having a small desk, so I'm having to write on, keep the roll book on the back of the bed here. Okay, so right now we're only missing Kelly, which may be about the first time she's missed all term. Jalen, I think, is still out. And Jared, I think, is still out. So good attendance today, but some people who are usually here are not here. Hopefully they'll be able to get here later. It's good to have Sharika in now. Okay, and this denominator here would then be 1 plus cosine u. Okay, so here are the two forms that you'll see on the next slide. So hang on, get a good shot of these in your mind, and let's see what we've got here. There we have tangent u over 2 is 1 minus cosine u over sine u, or sine u over 1 plus cosine u, whichever you happen to want to use. Okay, now you might also ask yourself, how can you have two possible answers here? Well, it depends on where you are on the, I want to say unit circle, whatever circle you're on, which quadrant are you in? If you're in a quadrant where sign is positive, you use the positive one. If you're in a quadrant where the sign is negative, use the negative one. That's why you determine the signs of the SIGN signs of the SIN sign of u over 2 and cosine u over 2 depend on which quadrant the u over 2 resides. Where it is, Waldo. Okay, so let's do example 5. Find the exact value of sine of 105 degrees. Wait a minute, I don't know what sine of 105 is. That's not one of my favorite angles. But if you think about it, 105 is exactly 105 degrees is exactly 1/2 of 210 degrees, isn't it? And we do know what the sine, well, we do know our values for 210 degrees. If not, we'll remind you, okay? So this is the same as saying the sine of 210 degrees over 2. Well, that's going to be plus or minus, we'll come back and wipe out one of those in a minute, the square root of, and remember, if you don't remember, look back, that's 1 minus cosine of 210 divided by 2. So 1 minus the cosine of the 210 degrees. This was the half angle of that one, okay? over 2. All right. Now, in the first place, where in the world are you, Waldo, at 105 degrees? Which quadrant? First, second, third, or fourth? 105 is past 90, but less than 180. So you're in the second quadrant. What is the SIGN sign of the SIN sign in the second quadrant? It's positive. So wipe out that minus sign. Okay? Now, we have the square root of, the positive square root of 1 minus, now what's the cosine of 210 degrees? Okay, now let's forget about 105, 210. Okay, 210. Here is 90. Here is 180. So 210 is 30 degrees past 180, right? So, and it's in the third quadrant. Cosine, oh, here comes Jared. Okay. Got it. Or actually, so Jared's here. So we're now only missing Kelly and Jalen, I think. That's all, I think. So fantastic. And let me just count and make sure I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Should be, yep, 15 students here. Got it. Okay. Now, cosine of 210, because in the third quadrant, which is where you are with 210, this is a 90, 180 plus 30 will be 210. Okay, cosine is negative, so that's going to make this sign positive. Okay, now the reference angle for 210 is 30 degrees. Well, what's the reference angle? What is the cosine of 30 degrees? If you think about it, that's your square root of 3 over 2, right? And then take that and divide by 2. All right. Now, the rest is just messy math, okay? You got the trig part done. This would be 2 plus root 3. What I'm doing is multiplying the numerator by 2 and the denominator by 2, because 2 over 2 is 1, okay? So this will be the square root of 2 plus root 2 over 4. Okay, root 3 over 4. Now, that's not a particularly pretty number at all, is it? Oh, and I guess you could, and it's a good idea to, rewrite that as the square root of 2 plus root 3 under the square root here over 2, because you can take the square root of 4 as 2. Okay, so that's what I'm going to do on my handy dandy calculator here, which is also my telephone. Get logged into it, find the calculator mode. Okay, clear what's on there. All right, now because I got square roots, I'm going to turn it sideways to get it into scientific notation. Okay, and that will be, now I'm going to start with the innermost problem there. That's the root 3. So I'm going to do, because on this phone it's not as handy as a calculator, I have to do the 3, take a square root of the 3, add to that 2, make that an equal sign, take a square root of that, and then divide that answer by 2. And I get something on the order of, okay, they asked for the exact answer. There's the exact answer. I'm sorry, I should have just stopped while I was good. That's the exact answer right there. Now, what is the approximate answer? Because to me that doesn't make a lot of sense. that's approximately equal to 0.966. Now, one reason I did that is I know the sine of any angle in the world has to be between plus and minus 1. I wanted to make sure this was between plus and minus 1. It is. It's awfully close to 1, but it's not beyond 1. The sine of an angle cannot be 1.1. Never, ever, ever. Okay? And that's one reason I did want to check and make sure that I had it at least seemingly right. Okay? So, let's see how the book did it. They got square root of 2 plus square root of 3 all under, okay, square root of 2 plus root 3 all under the square root over 2. And that's the answer we got. Okay. After every example, there is, of course, a checkpoint. Please do the checkpoints. Okay? You'll find them handy. This one's on the PowerPoint, so let me clear my print here and see how they did it. Begin by noting that 105 is exactly half of 210, and that's what we did. Then using the half angle formula for sine of u over 2, which would have been 210 over 2, and the fact that 105 lies in quadrant 2, that way you can wipe out the minus sign and just use the positive square root. That would be the square root of 1 minus cosine of 210. Twice the angle that's here, divided by 2. Okay? And the rest of it's math. Okay? That would be 1 plus, equal to the square root of 1 plus the square root of 3 over 2, cosine of 30. Okay. There was a minus here, but because cosine of 210 is in the third quadrant, that's a minus number, so that's going to make that a plus, and the cosine of the reference angle, 30, is root 3 over 2, and that's divided by 2. Now, they didn't show you how, but if you multiply numerator and denominator by 2, that gives you this to be 2 plus root 3, and the denominator would be 4. Square root of 4 is 2, so that's the square root of 2 plus root 3 over 2. The positive square root is chosen because sine of 105 is positive because 105 is in quadrant 2. The cosine changed signs because it was in the third quadrant. The 210 was in the third quadrant, and cosine in the third quadrant is negative. Okay. Now, they're skipping example 6. So let's go back and do on the whiteboard example 6. Find all the solutions of this equation. Okay. 1 plus cosine squared x is equal to 2 times cosine squared this pen is not doing too well today, x over 2 in the interval 0 to 2. I say 0 and write a 2. 0 to 2 pi. Okay. Now, what's wrong with the picture? Well, we got cosines. In fact, they're both cosine squares, so that seems okay, except they have different arguments. Well, those are not the same functions, okay? Even though they're both squared, they're both cosine, but they have different arguments, so they're not the same functions. So it looks like we need to use our half angle formula to do this. So let's go over to the side here and see what the cosine of x over 2 is. Well, we know it's going to be a plus or a minus, and that's a problem because we don't know what quadrant this is in. The square root of 1 plus, if I could get the pen to write, cosine x divided by 2. But then the good news is we're squaring that cosine x over 2. So when you square this, you lose the plus or minus and you lose the square root. So this is what we've got now. 1 plus cosine squared x is equal to 2 times this entity here. Okay? Well, guess what? That entity has a 2 in the denominator, so this 2 is going to wipe out that 2, and you're just going to have 1 plus, yuck, this thing is so aggravating, cosine x. Okay? Now, what we can do here is divide both sides, subtract 1 from both sides. Now, that leaves us with an interesting problem. This becomes cosine squared x minus cosine x if we subtract cosine x from both sides. Because this is a quadratic, you usually want that to happen. Okay, so that gives us a 0 here, which is a very good thing to have because of the zero product principle. What we do here is factor. Factor out a cosine x, okay, that's an ugly x, and that leaves us a cosine x minus 1, and that's equal to 0. Well, this is a product of two numbers equaling 0. That means one or the other of them got to be 0. So either cosine x is equal to 0 or cosine x minus 1 is equal to 0. Well, what are the values between 0 and 2 pi when x is between 0 and 2 pi where your cosine would be 0? Well, cosine is 0 at all the half pi's, so that would be pi halves, that's between 0 and 1, 2 pi, I'm sorry, and 3 halves pi is the other half pi between 0 and 2 pi. Over here, add 1 to both sides, and you get cosine x is equal to 1. Well, where is that true between 0 and 2 pi? Well, you know when x is equal to 0, that is cosine of 0 is 1. And then from there on, you don't hit 1 again until you get to 2 pi, but 2 pi is not in the interval. So here are the three values: x equal 0, pi halves, and 3 halves pi. Those are the three and only three values in that interval where that equation should be true. Now, this is not shown on the PowerPoint, so let's see what we've got. X equals 0, x equal pi halves, and x equal 3 halves pi. Perfect. Okay, they do show the graph of it, and those two graphs superimpose, but they show more than the interval from 0 to 2 pi, but that's okay. They're just showing that those are the same intervals, same values. Okay. As in every example, after the example is a checkpoint. Please do the checkpoint. All right. Now we're ready to go back to the PowerPoints. Lots of points here. What's your point? Okay, go back to 5.5 if I can find it again. and go back to the slideshow. Oops, resume slideshow. Okay, that was the last one we did, example 5, when we did example 6 on the whiteboard. So now we're moving to product to sum formulas. Okay, I'll set my pen down before I drop it or something. And I think I'm also going to have to, because of this anemia, and get a little bit of a boost here. I hope I haven't made a habit of doing this, but I sure run out of energy quickly. So I taught my first class this morning, made it through that okay, but I am getting so tired right now. It's amazing. So here's the product to sum formulas. Now, you might ask yourself, are these more things to memorize? I say no. If you're a good memorizer and that's how you learn, okay, knock yourself out. Go for it, What I do, if I need them, I look them up, okay? But it's good to know that they exist. And here's what they are. Each of these product to sum formulas can be verified using your sum and distance formulas, okay? I mean, sum and difference formula. I can't read either. You know that cosine of u minus v is cosine u cosine v plus sine u sine v. Cosine of u plus v is cosine u cosine v minus sine u sine v. So if you added those or subtracted this one from that one, the cosine u cosine v go away and you're left with 2 sine u sine v. Take half of that and you've got sine u sine v. So these all come right from your sum and difference formulas. You have to monkey around, play around with them some, but you get them. So basically, that's why they call it, if you have a product and you don't know what to do with it, but you could do something with the sum, then this is the product to sum formulas. Here, the product of sines gives you the sum and difference of sines and cosines, okay, a difference in cosines and cosines. Here, a product of 2 cosines gives you a sum of 2 cosines, but it's a sum and a difference, okay. Here, a sine times a cosine gives you the sum of 2 sines, okay. So a product to sum formula, and here is a product of a cosine and a sine that is a difference of 2 sine formulas. So your product to sum formulas are used in calculus to solve problems involving products of sines and cosines of 2 different angles. Okay? Notice the u and v don't have to be related by any means whatsoever. You make that relationship on the right hand side. Once you're given the left hand side, you can make the relationships on the right hand side. Okay? Now, I've taught calculus for many years, and you do use these, but it's rare and occasionally. So by all means, don't try to memorize these. Look them up. There's too many plus and minuses in here in different locations that I would ever trust my brain to remember that I got it right. Okay, so hang on to it and look them up when you need them. I never trust memorization. If you were working for me and I gave you some problem that I wanted you to come up with a solution, okay, here's the deal, here's the business plan, here's the what we have to accomplish for this company. Okay, well, I think I remember that formula. No, I don't want you to remember the formula. I want you to look up that formula and make sure you got it right. If you're building the structure, the framework, the whatever it is for that company, I don't want you, okay, this is really unfair, but I'm going to do it. I don't want you like Boeing and say, oh, I think this will work. No, I want you to look it up and make sure that it works. Never mind, that was pretty mean, wasn't it? Okay, so let's get back our pad and pen here. Rewrite the product cosine 5x times the sine of 4x as a sum or a difference. Okay, now am I going to memorize the formula? No, I'm not. I'm going to look it up. And let's go back here. And what we have is cosine 5x sine 4x. That's this one down here. Cosine u sine v. And here, is someone sending me a chat, or y'all chatting among yourselves? If you're sending me one, go and get it out there, because if I open it up, everybody will see it anyway. If you're chatting among yourselves, that's fine. That's perfectly fine. Okay? Was that for me?
Yes, I was telling you I have to go back to work.
Okay. Oh yeah, well yeah, of course I can't keep you here. Okay, I'm recording, and I'll save this at the end. It'll be late tonight before it gets loaded into the playlist on Blackboard, because I've got class until 7:45. So glad you made it today, though. All right, thank you. All right, so we're using this one. Cosine u sine v is 1/2 of the sine of the sums minus the sine of the differences. Okay, so let's go back here and do that. This will be, this right here would be 1/2 the sine of the sum of those two, which would be 9x, and was it plus or minus? I think it was minus, wasn't it? The difference of those two, the sine of the difference, which would be sine x. All right, let me go back and check and see if I got it right. Yeah, I believe so. Rewrite the product as a sum or a difference. We rewrote it as a difference, and that's what it was. That's all you have to do. Don't do any more. We don't know what x is. We don't know what 9x is. We don't know it. That's all they were asking. Okay? Pretty simple question, simple answer. Let's see what they give as an answer. Using the appropriate product to sum formula, you see that cosine 5x sine 4x is 1/2 of sine 5x plus 4x minus sine of 5x minus 4x, which gives you 1/2 sine of 9x minus 1/2 the sine of 4x, sine of x. Now, I didn't distribute the 1/2 through. I don't know why they did, but they did. Perfectly fine. Very legitimate. Is that someone coming in or leaving? I don't know. I don't see anybody new here. Was there another message or chat for me? Okay. All right. All right. Now, any questions on that? That was example 7. Now, if we have a product to sum formula, then the question is, do we have a sum to product formula? And the answer, of course, is yes, we do. If they can come up with some other formulas for to use, they're going to. Okay? Occasionally, now this is an occasionally, and this really is an occasionally, it is useful to reverse the procedure and write a sum of trigonometric functions as a product. Now, most of the time, this is not. When I said the other was used occasionally, this is less occasionally, but it still can be used. That can be accomplished with the following sum to product formulas. Okay? Now, these come, okay. These are even harder to derive. They're not hard, but they're just more convoluted. And just here they are. I'm not going to try to derive them for you. The sum of two sines, different values for the sine, is twice the sine of the average between the two of them times the cosine of the half the difference between the two of them. Is that anything worth memorizing? No way. If you ever need them, look them up. Look them up, okay? In fact, in my mind, in calculus, you might run into something that goes from this side to that side. I can seldom think of any reason in the world you would go from this side to that side, because that's a more complicated thing than what you have here. If you've got this, you can usually deal with that, okay? If you got this, you want to find some easy way to simplify it. So most of the time these will go the other way, okay? It's a different kind of product to sum, but they're writing them this way. So I'm not going to belabor it. There's nothing, I would never, ever in the world try to memorize those things, okay? So if I ever need them, I'm going to look them up. And we're going to need them right now. Oops. Yeah, we got two examples, but they're not given in the text. I mean on the slideshow. They're giving in the text only. So let's go to our whiteboard. Okay. And clear. Does anyone need this scratch from before? Okay, we're going to clear that out of the way. And let's do example 8. Find the exact value of cosine of 195 degrees plus the cosine of 105 degrees. Now, you might say, you can just plug this in a calculator and get a very good answer. That's not what they're wanting you to do. They said exact solution. Well, I don't know exactly what the cosine of 195 is, nor do I know exactly what the cosine of 105 is. Now 105, because we had it before, is exactly half of 210, so I could get that one, okay? But 195, that's not half or double anything that I know of. Let's see what happens if you double that. You get 390. And I'm not sure that's one that I know, okay? But because we just did the half angle, the sum to product formula, let's go see what that one is. Cosine plus cosine. Whoa, I'm sorry. Well, rather than going back to the slide set, just flip back in your book. Cosine U plus cosine V is equal to 2 times the cosine of the average of these two, which is 195 plus 105. This pen just does not write worth it anything. Okay. Sometimes. Other times it does okay. Over 2 times, this is the product part, the cosine of 195 minus 105 over 2. Okay, so let's see what that is. 2 times the cosine of, what's the average? So let's add those two together. That gives you 300, right? 195 plus 105. 5 to 195 would be 200, and then another 100 would be 300. Half of 300 is 150 degrees. Times the cosine of the difference between these two happens to be 90. Half of 90 is 45 degrees. Now, it just happens to be that both of those are angles. We know exactly what their values are. Now 105 is between 90 and 180, right? It's 30 degrees short of 180. So that's its reference angle. Cosine in the second quadrant is negative, and 150 is in the second quadrant. So this will be 2 times, and what's the cosine of the reference angle 30 degrees was minus the square root of 3 over 2. Now, cosine of 45, we know and love that one. That's square root of 2 over 2. Okay? So one of these 2's is going to cancel one of those out, and that gives you minus the square root of 6 over 2. There's the exact value of the sum of those two angles. Now, why is this not very practical? Okay? Well, you'd have to have two angles that the average of the angles is one of the angles you know, and the half the difference between the angles is an angle you happen to know. And that's going to be a very, very, very rare situation. So, hey, how often does that arise? Not very. Whereas, pull out your calculator and just do what the cosine of this is, cosine of that, add them together. You're going to be close enough for government work. So, I'm not too impressed with the sum to product formulas, yet they're going to find a way to make it seem like, oh, this is something you need to know. And example 9 is one. There is a checkpoint after example 8. Example 9 is another one, and they will make this seem like this is something you need to know. I think I'm going to clear the screen. Does anyone need this left up a little bit longer? Yeah, I want to make sure I got the same answer the book did, minus root 6 over 2. Good. Oh boy, my stomach's saying, feed me. Okay. I think it's because I drank that soda. It's saying, hey, I want something else. Let me get a little bit more. So I can try to quieten that a little bit. Okay. So this one you can go to larsonprecalculus.com for an interactive version of this type of example. And here's what it asks you to solve. If I can find my pen. There it is. Sine of 5x plus the sine of 3x is equal to 0. And unfortunately, this is one place that maybe you'll run into something like this far more frequently than you would something like example 8. That could be something you needed to do. Okay? Well, if you remember, well, don't remember. Go back and look. What is the sine of 5x plus the sine of 3x? Well, that's the sum of two sines. So that's going to be 2 times the sine of the average between those two, and the average between those two is 8x over 2, that would be 4x, okay, times the cosine of the half the difference between those two. Well, the difference between them is 2x. Half of that is just x, and that's equal to 0. All right, now, this I can easily, well, not easily, I can think of a time in calculus or somewhere where you might need to do something like this, okay? Now, remember what you got to do here, though. You've got to get, well, firstly, 2 is never equal to 0. So you could solve first for this, and it didn't give you a range to do, so you're going to have to do a general solution here. The sine of 4x either is 0 or cosine of 4x. No, cosine of x is equal to 0. Okay? Now this isn't too bad to do. You know here that 4x is going to be some multiple of 2 pi. Let's just call it 2n pi. Okay, 2n pi. And divide both sides by 4, and you get x is equal to n pi, that pen will not write, over 2. Okay? Over here, where it's x equals 0, that are any of your half pi's. So that would be pi halves plus n pi. Well, guess what? Aren't those the same answers? Okay. Well, not quite. Not quite. Because this would include, when n is equal to an even number, that would give you a pi. So this would be, but all of these would be included here. Okay. So I think this is your answer right here. Let's see what they get. I've done something wrong. No, let's see. Oh, I'm sorry. Yeah, I did do something wrong. Remember, sine is 0 not at just the 2n pi's, it's at n pi. Sorry about that. This is at n pi. Okay, let me clean this up, so I'm sorry about that. It's at pi, 2 pi, 3 pi, 4 pi. So this should be n pi. Sorry about that. I don't know where my brain was. So when you divide by 4, it's n pi over 4. Now, this one is correct, but all your quarter pi's, all your half pi's are also multiples of quarter pi's. So therefore, this wasn't necessary. So it's all your n pi over 4. Okay. Now, why? Yeah, and that's how they phrase it. Okay. They do show a graphic of it, and it's there in the book. If you don't have a book or can't look at it, I will show you what the graph of that looks like right there, and you see, sure enough, it crosses or touches the x-axis at every quarter pi. And that's only between 0 and 2 pi, I think, so it goes on infinitely because they didn't tell you any fixed interval. And there's a checkpoint at the bottom. All right. Any questions on that one? Sorry I messed up before we move on to the next one. Okay. So let's go back to applications. How are we doing on time? Uh-oh. We're out of time, aren't we? Yuck. I had hoped to finish this today. So we'll be starting next time on page 387, applications. Now, before y'all start bailing ship, let me give you your homework exercises. Any of the odds 7 through 13, they're all at Calc Chat. 9's at Calc View. Any of the odds 15 to 19, they're all at Calc Chat. 21 to 23 or 23, they're both at Calc Chat. 21's at Calc View. 25's at Calc Chat. Any of the odds 27 to 33 are at Calc Chat. 27's at Calc View. 35 to 39 are at Calc Chat. 37's at Calc View. 41 and 43 are at Calc Chat, 41's at Calc View, 45 and 47 are at Calc Chat, 45's at Calc View, 49 and 51 are at Calc Chat, 49's at Calc View, 53 and 55 are at Calc Chat, 53's at Calc View, 57 and 59 are at Calc Chat, 61 and 63 are at Calc Chat, 63's at Calc View, 65 through 69 are all at Calc Chat, 65's at Calc View, and we'll pick up the application problems next time. Now, the reason I said I don't want you leaving yet, okay, I want to know, basically, we're almost through with Chapter 5. That's why I wanted to be through with this today. We didn't quite make it. So we'll pick this up the Tuesday after Thanksgiving. I hope all of you know next week is Thanksgiving week. On Thanksgiving week, there are no classes. We will be on campus, well, not on campus. We will be at work Monday, Tuesday, and Wednesday. We have professional development, that kind of stuff going on Monday, Tuesday, and Wednesday. So you can, maybe hard to get in touch with us, but you can try and get in touch with us. But the offices are all open. So if you have any business to do with the school, it will be open Monday, Tuesday, and Wednesday. However, let me warn you this. I know you can catch people Monday, Tuesday, and Wednesday morning, but the Wednesday before Thanksgiving, it's very, very likely that some administrator, somebody is going to say, hey, why don't y'all go on home for Thanksgiving? So I would not bank on doing any business in any office afternoon on Wednesday of next week. I bet you some of the offices will still be open, and you probably can get things done, but I wouldn't risk it. If it needs to be done, get it done. Sometimes Monday, sometime Tuesday, or sometime Wednesday morning. Okay, now, the rest of us will probably still be at our homes or wherever we are doing professional development. You may be able to get in touch with us. I don't think they're going to occupy us the entire 2.5 days or 3 days, but they will keep us sort of busy for part of the time. We'll probably be Zooming and that kind of stuff, so we may not be all that reachable. All right, but here's the question I was going to ask. Since we're so close to finishing Chapter 5, do you want me to go on and post the Chapter 5 test so you can work on it over this long weekend that you've got? Yay or nay? Say again? Okay, that's what I thought. Okay, so I'll put it out there. It won't be immediately. I might be able to get it out in my lunch hour. Well, I've got 2 hours in the middle of the day. I've got office hours. I eat lunch one of them and then in the office the other. So if I can get it out, then I will. Otherwise, it'll be this evening. If I don't get it out this evening, I won't get it out tomorrow morning because I'll be at the clinic getting a transfusion, but maybe I'll get it out tomorrow afternoon or something. So sometime or another, I'll get it out there. I can't swear when, but I'll get it out there. Good deal. Now, the last thing I want to say is Thanksgiving's next week, and I know it's real traditional to be with family, to be with friends, to enjoy yourselves, and I really hope you do, but please be safe. Please be safe. I want to see you all back here after Thanksgiving. I don't want you sick. I don't want some family members sick. I don't want you quarantined. I don't want any of that to happen. Save it, okay? Be safe this Thanksgiving so you can share future Thanksgivings with family and friends, because this virus is all over the place now, and it's rampant, and don't risk it. Please don't risk it. All right, have a good Thanksgiving, even though you may be a little more isolated than you normally are. Be safe. Take care. All right, I'm going to stop sharing now. And does anyone have any questions before I end the meeting for all of us? Anything? We meet the Tuesday after Thanksgiving. We don't have any classes next week. but then we'll meet the Tuesday after Thanksgiving. Okay? And then we only have 1 week of class then. That we meet Tuesday and Thursday of that week, and then the next week is final exam. Okay? Sorry about that. This is coming to a rapid end here. Okay. Any other questions? Great question, by the way.
Yeah, I have a question.
What's that?
So, in my English class,
Right.
I haven't had anything posted since like week 6, and like I've emailed and messaged and everything. I haven't gotten the answer. Who could I talk to about that?
Okay, is that an online class or a virtual class?
Or just online?
Online, not you don't ever meet as a class.
No.
Okay. And it is an English class, ENG, right?
Yes, it's
Okay.
I can't remember.
Okay, right. 251, 252, 261, 262. Yeah, one of those. Okay. I would contact Miss, I can't pronounce her name well, Vayuka Masimasi. It's V Masimasi, VMASIMASI. She's the department chair of that department, and let her know that you have not heard anything since week 6. That sounds fairly serious. Now, that wasn't a mini-term class, was it?
No.
It was not. Okay. Yeah. You probably need to get in touch with Miss Mossy, and she's the department chair of that one.
He posted the week 10 folder, but there's no work.
Okay. Okay. You can see it in Blackboard, but there's nothing posted for you to turn in. Yeah. Blackboard sometimes screws things up. So, and you tried to get in touch with the instructor, email and that kind of stuff, right?
Yes.
And Blackboard messages, have you tried that?
Yes.
Okay, well, yeah, I would definitely get in touch with Miss Mossy and say there seems to be a problem with Blackboard or something. So, and it's dangerously close to the end with not a lot of, for several weeks blank there. That's not a good situation. Right. Wish I could help, but I don't know any way that I could.
Alright, thank you.
All right, glad to. Anyone else? Anything else before I end the meeting for everybody? I think this is week 14. The week after Thanksgiving will be week 15, and final exams week will be week 16. Yeah, so this is week 14. Okay, that'll be fine. Y'all can always catch those up anytime. Yeah. Okay, say that one more time. I missed it. I was talking. Okay, yeah. If you are behind in homework and want to turn in back stuff, you can turn that in next week anytime you want to. That includes tests too, please, okay? But there is no week out there for next week. This is week 14. The week after Thanksgiving is week 15, and the one after that is week 16. So there is no Thanksgiving week out there on Blackboard. Okay, we just skipped that one. Yeah. Glad to. Good question. Any others? Okay, was that a question? Okay. I think it may be Courtney's microphone's opening, but I can't make out what you're saying. Okay. That may have been just an accident. Okay, so take care, folks. Be safe. We'll see you on the Tuesday after Thanksgiving. Bye-bye.